Here's a relatively nice and simple rigid body dynamics problem. So this is the kind of stuff that you would see if you're doing any kind of engineering, whether it's civil or aerospace or mechanical. And this is probably something that you maybe do in your first year. So this question deals with a slender bar which has a mass of 20 kilograms and it's pivoted at point O and it swings freely in the vertical plane. So initially imagine that this bar is being held by someone and then it's released, and the moment it's released, the before it got any angular velocity, the question is what is the reaction force exerted by the bearing on the bar. So in other words, what's the reaction force at the hinge, right? So what I would normally do in this case is, as usual, just draw a free body diagram. So in this case we have two forces or three forces depending whether you look at components or not. So we have weight, and then we have the horizontal reaction Rx, and we have the vertical reaction Ry. And what we can then say is that Rx is equal to the mass times the acceleration in the x direction. Those accelerations, both ax and ay, refer to the acceleration of the center of mass, which is here, because the bar is uniform. And then ry minus mg is equal to m times ay. And we also have the equation for rotation, which you can take it about any point, but I'll take that about, can do this in a few ways actually. I'll do that about point O. So I'm gonna say that the moment about point O is going to be equal to the moment of inertia, which is a third ml squared, times the angular acceleration alpha. And that moment is given by, so if we take it about point O, that's going to be given just by the weight. So that's minus mg L over 2, like this. So we can cancel out the m, we can cancel out the l's, and we end up with minus g over 2 is equal to alpha L over 3. So that gives us that alpha is minus 3 over 2g over L, which is nice because now we can find, we just found the angular acceleration by itself. But now we have to think of a way to relate it to those other two equations, and this is where we use Euler's equations for acceleration. And here's how we do that. So I'm gonna say the acceleration of c is equal to the acceleration of O plus the angular acceleration cross OC, and then minus omega squared OC. This term is zero because the bar is still at rest in this moment, so there's no angular velocity. So we can say that the acceleration of point C is equal to zero, because the hinge is not going anywhere, plus, and then we have I, J, and K, and then we have 0, 0, alpha, and then OC purely has an X component, so that is L over 2, 0, and 0. So that's equal to J times alpha L over 2, which means, interestingly enough, and we might have been able to expect this, this acceleration of C only has a J component. So basically the I component or the X component is 0. And if this is 0, it means this is 0. And if this is 0, it means this is 0. So the only reaction that's occurring at the hinge in this particular instant when the bar is horizontal is Ry. And we got a formula for that. So we have AC, which only has this component that is the same as AY. So AY is the same as alpha times L over 2. We know what alpha is, so alpha is minus 3 over 2 g over L, and then times L over 2. So we cancel out the L's, and this is minus 3g over 4. So the center of the mass of the bar in this instance is falling straight down with an acceleration, or it's falling such that the acceleration is straight down and the value is 3/4 of the gravitational acceleration. Okay, so if it's not in free fall, and it can't be in free fall because it's hinged, and if it's falling with this acceleration, which is 3/4 of gravitational acceleration, it means there must be a force which removes that 1/4 of its weight, and that's the reaction, and we're gonna show that. So if we use the second equation to find Ry, so Ry is going to be mg plus may, right? So it's going to be mg plus m, and ay is minus 3g over 4, which is just mg over 4. So that's it. Basically, this tells us that regardless of the mass of the bar, the reaction that's acting in this moment when the bar is horizontal is 1/4 of its weight. And you can put the numbers in, and you're going to get some value, but that's how I would think about doing a question like this. And that's the end of the question.